Welcome to the Data Structures online class. In previous video, I discussed about how we are deleting a node or element from a double linked list at the starting and ending. But in previous video, I discussed by using a flowchart. Am I right? I used the diagrams. Now I'm going to convert the diagram into a programming. So presently I am using C programming. So I will convert that flowchart into a C programming. Now, if you see, this is the flowchart or process for deleting a element at the starting of the linked list. Am I right? It contains the 8 steps, but 8 is nothing but it is the end of the process. Am I right? So I need to consider 1 to 7 steps. So for what steps will what do? What is the functionality of the each and every step already explained in the previous class. Okay, now I'm converting it into a programming. See, if you see, these are the 7 steps I have in my flowchart for deleting element at the starting of a double linked list. So for everything we need a structure, am I right? If I want to delete a element in a double linked list, I need a double linked list. Am I right? So for that I am created this structure. So you can see structure node. Okay, that structure node is nothing but node is my double linked list. So double linked list contains three fields. Am I right? The first one represents the previous element address, second represents value, third represents next element address. All right, so that's why node double linked list contains three members. The first member is the previous pointer. The pointer stores the address of previous element. And next, int data. Why I use the int means I'm storing the integer values, so that's why I use the int data. The third member, it is again pointer, is for next. I am storing the next element address in this next address field. All right, so these two are I'm creating for this node structure. I'm creating for that node structure. That's why I created so struct node previous, struct node next. So this is the structure for double linked list. If it is single linked list, just remove the first line. What is that one? Structure node previous. Why? Because in single linked list, I have only two fields. The first one represents data and second one represents next element. So here, if I delete this first line, that node previous element or address storing previous, if I delete that one, then it will simply represent as a single linked list. So right now I represented for double linked list. Now if you can see here in the bottom, I declared a function for writing a program. Sorry, I created a function. Here I declared a function. Later in that function I will define the process, or I will define the what the function should have to be done. What is the process? These 7 steps. Am I right? These 7 steps should be written in this function. What is my function? Remove at start. So I am going to write the complete program in remove start. Now see, so I created in previous slide I created a function. Now I'm giving the definition for the function. So now if you consider this complete algorithm, here I use the temporary variable. Am I right? Here I use the temporary variable. So this temporary variable also stores the address. So it must be represent with the node or that structure. So for that one, first I am creating a temporary variable. So if you consider any algorithm, if you have these type of extra variables, first create variables, then go to the process, step by step process. Am I right? So in this I have only one temporary variable. So for that one I created a temporary variable for structure. Now I'm going for the first step. What is the first step? In first step I'm checking whether my given linked list is empty or not. How I'm going to check? If it is null or not. Now here it is checking. Am I right? It is checking. So as I previously explained, for conditions we have two types. So conditions are represented by rhombus. Am I right? By rhombus. But rhombus can represent in a programming by using if blocks or like loops. But which one we have to use? That is the main question. Now if you see, Here that first statement or the first step only executing one time. So one time execution means it must represent if condition. If it is executing multiple times, then I have to go for while. So here the first one represents only one time. So here I am using if condition. Now for first statement, if head is equals to null or not. Okay, fine. Then if it is true, then it will go to the step 2. Am I right? It will go to the step 2. See, if one is true, that means head contains null, means there is no elements in double linked list. So what I have to do? I have to put a error message like why? Because if the no elements are available in the double linked list, that means I cannot delete a element from the double linked list. Am I right? So I need to put a error message. Now where I have to put? See, here 2 will be executed if it is true. Am I right? 1 is true, then 2 should be executed. So true means, that means it should be come between if block. True means it should come with between the if block. So here I am writing the error message. Am I right? So first one I created a if statement. So am I right? If it is S, the second statement will be executed. Now, okay, if double linked list contains some values, what will happen? Then I will go to the step 3. What is step 3? Here I am storing the value into a head value into a temporary variable for further purpose. See, 1 is for checking, 2 if it is executed, then from 3 onwards it should be false. If 1 is false, then 2, 3, 4, 5, 6, 7 should be executed. So 2 I return in if block. Why? Because it is a true. Then the 3, 4, 5, 6, 7 must return in the else block. So the for that one I created else. Am I right? I created else, and in third step what I created? I stored the head value into a temporary variable. Now I am going for the step 4. In step 4 what I am doing here? In step 4 I am checking whether the temporary next variable is null or not. Why I am checking? As I previously explained, in this for deletion, first I will check whether it is a empty linked list or not. If it is empty linked list, I will put a error message. And second, I am checking whether it is a lonely element available in the double linked list or not. So for that purpose, I am checking the I'm using fourth statement. In fourth statement, I am checking whether it is a single element available in the linked list or not. How I am checking? I am checking your head next equals to null or not. Sorry, temp next equals to null or not. Either I can use head next equals to null or not. Why both are same? Why? Because temporary contains the head value. Temporary contains head value. So temp null equals to null or sorry, here I can use double equals to. Okay, you can correct it. Now temp node double equals to null or head next equals to double equals to or not. Am I right? Here I am checking. If it is, then I will go to the step 5. What is step 5? I simply put null as a head or a head value as null. Why? Because if it is the only element available in the linked list, then the single element I am deleted, then linked list will become as a empty. Am I right? So here I am writing. Now here I am checking if temporary next variable is null or not. If it is null, what will happen? I will go to the head equals to null. Am I right? I am emptying the linked list. Now it goes to that step 7. Why is step 7 here? So before I am going to the step 7, first I need to complete step 6. Why? Because step 5 and step 6 both are redirect into the step 7. Am I right? 5 and 6 both are referring to the step 7 after completion. So these two 7 must be count for common for 5 and 6. Am I right? Common for 5 and 6. So I will write, first I will complete these two steps, then I will write 7th step. Okay. Now so comes to the 5th step. Here if it is true, if it is true, then I will make head element as null. Then if it is false, then I will go to the sixth step. In sixth step, what I'm going to do? So here fourth step is false means I have more than one elements in a double linked list. So I will delete the first element and I move the head to the next element. Why? Because I'm deleting at the starting. Am I right? So I will move. This process will be done. So head, sorry, head transfer to the next element. Head transfer to the next element, that is temporary next head previous become null. Am I right? So why head previous? See, first I have first element, second element. If first I changed the head to the first to the second. Am I right? First to the second. Now this second must not represent this first one. Now, so that's why I put head previous equals to null. Head previous equals to null. Then I will go to the seventh step. Now I will do that one. The else condition. Why I use else condition? See, 4, if it is true, 5. So it comes between if. So 4, if not true, it comes to the 6. So that means fourth else should be a 6. Am I right? So that's why I put in the else block. So these two are done. Then these two go to the seventh step. So that's why I return outside of if and else block. The seventh statement I return in outside of if and else block. As you see, now here in seventh step, what I am going to do? Emptying the temporary variable. See here, I deleted from the linked list only, but I didn't delete it from the memory. So in seventh step, what I am going to do? In seventh step, I am deleting from the memory also. For that deletion, I will use the free function. In C, I will use free function. So this is the complete program if I want to delete a element from the starting. So as you see, the first one I created a temporary variable. Next, this here it is a step 1. I am checking whether it is a empty linked list or not. Here if it is empty linked list, I will execute the or I will put the error message. Then here it will be the third step. In third step, what I'm going to do? Temporary, I will store the head value into a temporary. And next, I'm checking whether it is a lonely element or not. Here I am checking it is the fourth step. If the fourth step is executed, then I will go to the head equals to null. Alright, I will put head equals to null. It is the fifth step. If it is false, then I will go to the sixth step. Here in sixth step, I will write like this. I will shifting the head element to the next and putting the head previous value into a null. Here I am cutting the relation with the first element. Am I right? Previous first element. So that means I deleted from the linked list. Now here I am deleting the data from the memory. Here I am deleting from the linked list. Sorry, here I am deleting from the linked list. Here I am deleting from the data. Now finally I will put a success message. This is the complete program if I want to delete a element at the starting of a double linked list. Okay, if this complete process, if I am deleting from the double linked list. Okay, if I want to delete an element from the single linked list, what I have to do? Simple, don't do any big changes, just simple change. What is the change? See, if I delete this line, then it will automatically works for single linked list, the single linked list also. In single linked list, if I want to delete a element from the starting, just complete program, just delete this line, then automatically it will work. Why I deleted this one? Why? Because in single linked list, I am not storing the previous element address. I am right. I am only storing the next element address. So that previous, if I deleted that previous, then automatically work for single link. So for only one program, it can work for single linked list and double linked list deletion at the starting. So I hope everyone understand. So now I'm moving forward. If I want to delete a element at the end of the double linked list, if I want to delete a element at the end of the double linked list,